Like, sorry, let me get this guy going. So if you take something away from one side, you have to take the equal thing away from the other side. Or you have to do the same thing to both sides. And at this point, I really hate bringing this up, but if you haven't heard this yet, it's often related to a scale. So if you have 5 pounds on this side and 5 pounds on that side, if you take 1 pound away from here, to keep the scale balanced, you better take 1 away from there. If you double this weight here, you better double this weight there. Whatever you do to one side of an equation, you have to do the other side, or else it's not an equation anymore. It's not a true equality anymore.
So if we see a problem like that, just do this and then do that process. And
yeah, if you want to. If it's an option. If you don't want to work with the fractions,
yeah,
you can get the LCD and kill them.
Yeah, I don't want to work with fractions.
It will always work. You run the risk of getting large coefficients, possibly, but that's normally not nearly as dreaded as fractions are. Yeah. Okay. Any other questions? We got up to section 2.4. I think I gave like a little preview of 2.5 last time. 2.5 was just more word problems. So I'm hoping, I know that some of you guys don't have your book yet, but you desperately need to get something. I mean, if you don't have a book yet yourself, get it from the library, check it out. Go to the Math Study Center, check it out. You can use it in there. You have got to get started on this homework. I'm hoping to God there isn't anybody in this room right now who has not done anything out of chapter 2 yet. Chapter 1 should be, if not done, very close to done, and you should be in chapter 2 now, right? So I want you to realize last Wednesday I finished lecturing on 2.3, which is why I made the quiz today up to 2.3. Because a week later is when your homework is due, right? So I'm never going to make the quiz on something that I talked about that class before. Does that make sense? Mm-hmm. That's why I do the quizzes when I do. Okay, all right. Yes, ma'am.
Question about showing work. If it's like negative 7x equals 28, you already know like it's negative 4. You have to like do the minus or plus 7x on both sides.
Well, now you got me worried. Now I might want to see it, because what would you really do to that? What operation would you use?
Well, you would, I mean, yeah, divide.
Okay.
But I mean, like, do you need to show that part? Can't you just do x?
It's fine if you do that last step and you don't show me that. Okay. Just be careful. Don't start off. I'm seeing way too many people with this long, complicated thing, and you don't even do any work. The next step is x equals whatever. I'm going to assume it came from somewhere it shouldn't have come from. I've got to see somewhere. If I don't see any work, how can I help you? That's my bottom line. The reason that I grade homework and actually look at it is because I want to see your work and see how you approach a problem. Very often I'll see something somebody does and I'll say, oh, that's a good idea. I'm going to start teaching it like that. Right? So part of it is greed. I want to see what you guys do and see if I can steal anything. But most of it is I just have got to see your work. I don't know if you guys understand. Homework, if I could, I would make homework worth nothing. But the minute I do that, it doesn't get done. If I make homework worth too much, then way too many cheat. Because then, you know, if you get an A on the homework, you might pass the class. So I make homework worth, basically at the end of the day, it's worth about 5%. Which is still something. If you don't do it, it actually takes you down a decent amount. But it's not so much that it really should be that big of a thing to cheat. Right? So I'd much rather you honestly come up with the wrong answer than dishonestly have a right answer appear out of nowhere. I mean, that's a learning, that's what it is, making mistakes and learning. So I'll try to be forgiving. If I know a few of you guys can do a lot of stuff in your head. You got to get used to showing me something, right? Some kind of work. Any other questions from the homework or? Yeah.
So you said all homework to do the day of the quiz or test?
To make it not late. It's due by the day of the test.
And how long until the next test?
I put it February 13th. Yeah. Cool.
Okay, so like a little less than 2 weeks from today.
Yes.
Like 13 days from today.
12. That's okay. Yeah.
Whatever.
Something like that. But again, please, dear God, don't give me all your homework on the day of the test, unless you absolutely have to. The only reason I do that is in case something comes up. Like for me, my car decided to die on the way home yesterday. So I had to get it put in, and then I got it back this morning. But those kind of things happen, and I totally understand those kind of things because they happen to me too. Right? So I'm the teacher. It's easier for me to say, hey, guess what? I didn't grade in your homework. But at the same time, I want to be fair to you guys. Shit happens. I want to give you some time, but we're all human. You need a deadline. So please turn it in. A lot of you guys have been doing it. I love it. Turn it in as you get it done. Right? But you have until the day of the test if you need it. All right. Any other questions? Let's do one, well, maybe a couple examples out of section 2.4. Ooh, I like that one. This is page 117, number 24. No, this is 2.4. Yeah, I just want to review a little bit of 2.4 before I officially get into 2.5. We already did 2.5, to tell you honestly. 2.5 is rectangles and triangles, and we already did several problems like that. That's all 2.5 is.
The rectangle, you gotta do it twice.
Exactly. Okay. So, when you read through something like this, and hopefully enough of us have a book. Yeah, it looks like a decent number of you guys have a book. If you don't have a book, find somebody near you that's nice or that's mean that you can see their book. When you read through a problem, it's a workout that combines weight training and aerobics burns a total of 374. If doing aerobics burns 12 fifths as many calories, that's a lot. I sort of did. Well, yeah, he's got it right. 24. Yeah. That's why I said it so quickly, because I'm not reading them.
Come on, children.
It's not a pop-up. Don't worry about the 12 fifths and all that. What's the very first step? There's no math involved in the first step. Most of you guys seem to not want to do this first step, but those of you who do the first step will have a much easier time. That's all I can say. So what is the first step on this kind of problem?
You write them all.
Who are the players? What's involved in this problem?
Not the 374 calories.
No.
No?
It doesn't have anything to do with the numbers. It has nothing to do with this one's twice as much as that one or whatever. It has nothing to do with that. Just English-wise, what's involved?
Total and aerobics burns.
Aerobics and weight training, right? Calories burned by aerobics and weight training. You guys, I really, if you follow this advice, word problems will be so much easier. The problem people have is it's really difficult to read a word problem and go right to the correct equation. And that's what most people do because you don't want to be in this section forever, you want it over, but why waste any time if you're going to get them all wrong? That doesn't make any damn sense. So the first step is always just English. Write down what's involved. No numbers, no relationships. What's the next step? What's like the key step to go from English to math?
Find X.
Which one is just X? And in this case, which one is just X?
Weight training?
I love it. Aerobics burns 12 fifths as many as weight training. So I got to know weight training first to be able to figure out aerobics. So if I call weight training X, aerobics is 12 fifths of that.
And then of is multiplying?
Exactly. And it's kind of like a hidden of there. 12 fifths as many. 12 fifths of, right? So how do I write that? 12 fifths of the weights. 12 fifths x.
Okay.
And it really, the reason I like this is because it really hammers home to you that it is difficult because it is translating from one language to another. You write your language down, and then you write my language down, which I'm trying to make your language too. So this is what math sees these as being. And now we can write the math equation that will help me figure out the numbers. I can't do it with the English words. That's not going to help me figure out the numbers. So what's supposed to happen with these two things?
Do you add them?
Equation.
Yeah, a workout that combines weight training with aerobics. Combine these two to lose 374 calories, probably per hour, but it didn't say. Combine weights with aerobics to lose this many calories. So you can actually read the math equation. You can read it in English. Scary, but true. So now this should be the easy step, but what could help us out for the people that don't like that fraction sitting there? What could you do if you wanted to? What's the only fraction in there?
12 fifths.
Not add 5, but multiply by 5, right? If you multiply each piece by 5, if you wanted to, you don't have to. Because look what you're going to get there. That's the trade-off I told you about. When you do that, you're going to trade off for larger numbers. But this is 5x. What happens here?
It becomes 12.
5 goes away, so you get 12x equals whatever the hell that is. 1870? I don't know. Somebody help me out. Who's
No, I just have a question.
I don't have a calculator.
1870.
1870. Gotta show off there. Yeah.
So when you're, I gotta think. So when you're multiplying to get rid of a fraction, you just multiply it by the denominator to cancel out?
No. I am multiplying 5 times, you understood 1 here, right?
Yeah.
I am multiplying 5 times 12 fifths.
Mm-hmm.
What is 5 times 12 fifths? 5's cancel.
Okay.
So I'm not multiplying 5 by 5, they just cancel. So if I really want to write this out a little better, you can leave yourself some room. 5 times this, 5 times this, and then 5 times that. And here, this becomes a little fraction problem,
Yeah.
and you reduce. Or 5 times 12 is 60, divided by 5 is 12, because the 5 goes away. Right? Yes, ma'am.
So let's say we don't add the 5 in front. Do we multiply the 12 fifths by 5/12 to the other side?
I see what you're thinking about. So, why, I keep rewriting this thing. This is the same as what I have there, right? So this is okay. So your question is, could you just do 5/12 so that you would cancel that out, right?
Well, and do it to the other side, of course.
So you'd have to do it to this side and that side. So you'd have to do it to each piece.
Yes.
And you've just created another fraction that was just as bad as that one was. Do you see why? I want you to get this. If there's some other piece to the problem, if you multiply by the reciprocal, that piece is going to get it. And that's still a fraction. You really didn't make it any better. Whereas if I just want to get rid of my fractions for sure, I just multiply by the bottom. That's the only reason it's a fraction, right? It's because the bottom is not 1. So if I multiply by its bottom, it's gone. Okay. And then what's the next step here?
Like terms.
Yeah, so this one's not too bad now.
I have a question.
Yes, yes, sir.
Could you divide by 5 that 5x? Like, just take away the 5, or it has to be space, the 5 has to take that x?
Here?
No, down.
Here.
Yeah.
Oh, if you divided by 5 right now, you'd actually go right back to where we were. And I want you, let me make a big point of this. We can't go in and say, this is where I have a problem, I just want to change this piece, right? Because, for example, this is going to be kind of silly. 5 plus 2, well, let's say 5 plus 10 is 15, right? Let's say you don't like the number 5, you hate it. So you're like, let me just kill that. So now 1 plus 10 equals 3. That's neat. So you're not allowed to target a piece of an equation. The minute you do something to one piece, it's got to be done to all pieces, right? To keep it balanced. You can see that balance. If I would have just done this, now it makes sense. 1 plus 2 is 3. That makes sense. That kept the balance, right? So you can't target one piece to do something with. Yeah. And you really don't divide until the end. When you get your x's together, now I see what to divide by. So x equals 110. Cool.
Okay, I have another question.
Yes, ma'am.
Sorry. So, and if this was x plus like 6/8x, would you just multiply by 8,
Okay.
right?
Yeah.
Okay.
I was about to say 6/8 is a bad choice because you can
Well,
reduce
I know,
that.
I know, but I
But you
can
got it.
think
If it
of
was over
numbers.
8 instead of over 5,
You
like
just-
17/8, you multiply by 8. Why did I multiply by 5?
To cancel out
To
the
kill that
denominator.
5. What's the only reason this is a fraction? Because it's got a 5 on the bottom.
Okay.
How do I kill it? Multiply by it.
Okay.
That's the awesome thing about equations. Equations allow you, whatever you want to do here, as long as you do it over here, you're good. So how do you kill a fraction? You kill it by multiplying by its bottom.
Okay.
But the problem is people start getting a problem like this. If I said, okay, now add these, and then people multiply by 21. Are you allowed to do that here?
You have to make the 1/7 equal to the 21.
Yeah, you have to give them like denominators, but can I just multiply by 21 and kill it? No. Because 3
now you just
21st,
add it.
yeah, now you got to make it 8 21st.
Okay.
But I will have people that will cancel the 21 and make it just become 8. And I'm like, whoa, 1/7 plus 2/21 is 8. But you see where the problem comes from. They get so excited about having a way to kill fractions, they try to do it everywhere. Why is it legal here? There's two sides. Whatever you do to one side, I can do the other side. It keeps it balanced. Are there two sides here? No, there's no equal sign. There's not two sides. Nothing to keep it balanced, right? Okay, slowly but surely, yes.
Why you have to multiply 5 times x?
Here?
Yeah. Can't you just leave it like that? X plus 12x?
Well, again, it's the same idea. If I have 1 plus 2 equals 3. And do you see how it's really something plus something equals something, right? If I multiply this by 2 and this by 2, that looks like a square. I'll get 1 plus 4 equals 6. Is that true? So if I do something, and what I'm really doing here is overanalyzing this thing, but I really want you guys to get this. The step I'm sort of skipping is if I multiply this side by 5, I have to multiply this side by 5. And then what has to happen? Distributive property. So can he escape? No. So whatever I do to one side, I must do to the other side. But to me, it makes more sense to go ahead and just put it next to each piece, because it's going to go there anyway.
Okay.
So nobody can escape. Or else you get bogus stuff like that. Cool. Am I done with this problem yet? No. I'm not. X is 110. What's that? That's how many calories you lose there.
I forgot what it is.
And then 12/5 x is aerobics. X was 110. 5 goes into 110. 22 times. 22 times 12.
264.
Yes. Cool. So there's your two answers. How do you check yourself?
What you wrote yourself?
Check yourself.
You add the
264 plus 110 is 374. Thank you.
I got lost. What did you just do? Did you times 12 over 5 times 110?
Because what did we say from the very beginning aerobics was? 12/5 whatever x is. So once I know what x is, it's like dominoes. I figured out this, they kind of fall back, and now I know everything else. 12/5 times x is now known as 12/5 times 110.
Okay.
Cool. Yeah.
X plus 12, 5x equals 374. If I go there, I say x on 5.
Yeah, okay.
17.
So the way to do this without being afraid of the fractions
Yeah, I go there.
is this is 1 over 1 right now.
5 on 5. Yeah.
So you have to multiply by 5. So now you got 5 plus 12 is 17 over 5x.
X and now just reverse it when you do.
Yeah, now you can multiply by the reciprocal. Why? How many pieces are there over here? 1 piece. when you multiply this by 5 over 17, there's nobody else that will pick it up. That does cancel. Nobody else picks anything up. And notice this. What do we do to the 374? We multiply by 5, and we eventually divide it by 17, right? Look what's happening here. Multiply by 5, divide by 17. So that's the direct way to do this problem. Cool. Beautiful. I love it. Either way you want. Either way. Because you get the same answer either way. Right? Yeah.
So that's how you got the 264, was you just took 12 times.
12 over 5 times 110.
So you just times 12 times 110 and then divide by 5?
If you want to.
Okay.
Or a better way is to realize that, see, all I did was put the x in there, right? 5 goes into 110. 22 times. Think about this. 5 goes into 100. How many times? 20. And then goes into 10, another 2. So that's 22. Right? So I always try to cross reduce when I can. I'm just that way. So I don't get these huge numbers at the end.
Yeah.
Right?
Wait, I'm confused. I got 22. Wait, you.
5 goes into 110. 22 times. I'm just cross reducing.
And 12.
12 times 22 was the 264.
So you multiply the 5, or you see how many times the 5 goes into 110, and then you multiply the 12 by it?
Yes, this I am assuming we all know how to do.
Well, yeah.
Multiplying fraction. Yeah. That's all that is. So realize that's all this is. It's a fraction problem. I just don't know what x is yet. But now I do. Now you attack it just as if I gave you this problem to do. Now you cross reduce if you want to. If you want to multiply, you can. Just reduce at the end. Cool. Yeah.
I guess you do 12 times 110. And
Yes. Cool.
think about 5.
I like that way better too.
That's fine. That's fine. That's
Sounds
fine.
easier.
So some of us like this way, some of us like the other way. That's okay with me. Okay. Bless you. All right. So let's look at a couple out of 2-5. And let me let you guys try one, because I've been talking for way too much. The arms have got to be getting tired. Oh, I like this. Look at number 45. This is page 127. You're good. So read through that, see if you can set it up. Oh, cool. Just to help the booklets out there. Try to help the booklets. Let me see if I can do this. The plight of the booklets. Yay, magic. 45 right in the middle there. So my suggestion, try to draw a picture, write down the parts that are involved, get the math names, right? All the steps of the word problems. 5 there. Just gonna blow your minds. Who remembers what the name of this kind of triangle is, where the two sides are equal? Isosceles. I love it. Right? If the third side was also equal, that would be an equilateral. Cool. I like it. This is the one time that you're allowed to do something here and here. What's the first side and the second side? Remember, the third side is the one that's not the same length, right? The third side is 4 meters less than twice, which means I have to know these two first. They're both going to be x. If you say that anywhere, you are telling me they are the same. In this case, they are the same. It tells me they're the same. If there are two things you don't know, you can't call them both x unless you know that they are both equal, because that's what you're saying, right? Okay, maybe. The third side, then, how can that be written?
2x minus.
Good. 4 less than twice. So 4 less than twice. Remember, that less than is the evil one. It's not 4 minus 2x. It's 2x minus 4. It's always backwards. And then what's going to happen with these sides?
They equal 24.
I love it. So the perimeter is 24. So when you add all three sides, you get 24. Cool. So there's the first side, the second side, and the third side. I can find all three sides in my equation. The biggest mistake is people leave off one or both
X
x's.
is 5.
I don't know yet.
I got 7.
Yeah. I got 7.
I was just trying to figure it out in my head.
Oh, I see what you did. But I'm with you. I like that. But you made one little tiny mistake, and it's a mistake I do all the time too.
4x.
Yeah, good. So x, 2x is 4x. So here's where you have to be careful. Add the 4, yeah. But don't be discouraged.
Oh, yeah, the negative
Continue, yeah, continue doing it in your head. That's good. Good practice. And then the last step, divide by 4. So x is 7, so what's that mean? First side is 7. The second side is 7 what, by the way? Meters. Second side is 7 meters. Third side is twice 7 minus 4. Beautiful. 14 minus 4, 10 meters. Please, dear God, notice if you follow those instructions. First step, no math. Write just in English what it is. Translate to mathish. Which one's x? Build the other one off of that. Then what are they all supposed to do together? Do they equal each other? Do they add to be something? What? And now that should be the easy step. Solve what you set up. Okay. You guys are getting antsy. Let's take a break. Is that okay? Let's take a break? It's kind of a funny question. Yes. Come back 20 after.
Probably like the stupidest question we're gonna do. Okay, these two are kind of similar. I don't know. Can you do a fraction? Leave it in both?
Oh yeah, definitely.
So do I leave it this?
Just
or do I have
reduce
to-
it. Reduce it, yeah. So always
So would I
reduce it.
divide by 2 or would I make it
We can divide by 2 to begin with, and then it can go further, because there's more that can go into this.
okay, so divide by 2 on both of these.
And then keep going.
Keep going.
Because you can divide by more, like 6 will go on the both.
Oh, yeah. Okay, yeah, cause that was short. And then also, right here, I landed with above the same.
I like it. But look what you really get then. If you try to subtract 6V, what happens to it? Then they cancel?
Yeah.
So do you end up with a true statement or a false statement?
False.
Which means when that's true, the thing is true, it's never true, so there's no solution.
So it doesn't,
There's no
undefined
reason
is
that'll
not the
make
same.
it true. It's always false.
So would it
So
be
undefined is
considered-
not the same.
Oh.
Yeah, undefined is when you're trying to divide by zero. It's sort of what's going on, but really, what's the solution?
true.
No solution.
Okay.
Cool.
Okay, thanks.
Sure.
2.3.
Oh yeah, I know.
So that's still in the 53.
I know.
Okay.
And I think I meant to make it the last part, it's like a preview. But a lot of people have already done that homework, so I
That's up to the 13. Okay, so can I just add this on to the?
Exactly.
Porque no es esta la tarea del último.
Yeah.